these, and I want to let you know, I don't know, I think this perspective would be useful for you to know. I used to absolutely hate this, not because it's a bad topic, not because it's hard, but because the notation was awkward, right? And so, before I figured out what I figured out to make this easy, I was tempted to just sort of avoid this topic altogether, simply because my students would get frustrated. They couldn't keep the symbols straight, and I had a hard time keeping the symbols straight myself, and it was just this struggle. And I thought, why even bother? Let's just focus on other things that are easier for people to get. And then, like all great ideas, talk with someone and just stole their idea, or they gave it to me. I don't remember which it was. And so once I got a hold of this, then things got much easier. And now I look at these as worthwhile and easy and not distracting and not difficult for students to pick up. I think once you get the hang of this, you'll find, oh, this should be easy, instead of, where does the little symbol go and I can't keep them straight and I just give up, like that kind of thing. Hopefully you won't experience that. Okay, so I want to kind of take you through a process here of where our strategy comes from, and then we're just going to apply the strategy 3 times, and I think we should be able to do this in our class today. In these situations, we're going to be really consistent with what we did before in our little example of inverses, and we'll review those properties here in a second. But we're going to specify the original function to be named f, and instead of calling the inverse function f with a little -1 up there, we're going to call the inverse function g, right? So this eliminates some of the symbolic issues that we run into. And so instead of memorizing a formula, we are going to use some properties of inverses to develop the derivative that we're going to be using here. So let's review the properties. So for inverse functions, the blank and blank are switched. The x and y, the input and the output, are switched, right? And I'm going to use the words input and output specifically. We know that it means x's and y's. I know you know that. But I'm going to say input, output. You're going to see why that's useful here in just a little bit. Okay, so that's one property of inverses. And there's one other significant property that will kind of give us our start as to how we're going to do this. It has to do with composition. So if you compose 2 inverse functions together, and they really are inverses, what should you get every time? You should get x every time. Okay, so here's how this is going to work. I'm going to show you this little formula. You can memorize this formula. You can kind of keep the process in mind. I think if you do this enough times, you'll just memorize the formula just by default. But here's where it comes from. So we're going to start off with that first formula you guys said, f of g of x equals x. So we're going to start off with that right there. So our goal in this process is to find the derivative of the inverse. Derivative of the inverse. I want to say this now. I'm going to say this now. There might be some of you out there that are thinking, this is cool, he's going to show me a formula, but you know what? I'm not going to do the formula, because what I'm going to do is I'm going to take the x's and y's and switch them, and then solve for y, and then just differentiate that. It's not going to work. You might be thinking, yeah, it will. I'm saying, no, it won't. Not every time. Certain situations it will, but not every time. So please be focused in. Make sense? And I'll come back to that here in a second. Okay, so f of g of x is equal to x. The goal here is to find the derivative of the inverse, and we've defined the inverse to be g, so our goal is to find g prime of x. Make sense? Our goal is to find g prime of x, since we've defined g to be the inverse of f. The goal is to find the derivative of g. Make sense? So if we're going to be finding the derivative of g, and I've got this f of g of x equals x thing, then I'm thinking a good idea might be to find the derivative, find the ddx of that whole equation. So I'm going to just write ddx of the left side equals ddx of the right side. Okay, so the right side is super easy. ddx of x is 1. And then what kind of a rule do we have to use on the left side? Okay, use the chain rule, right? Because it's a composite, f of g of x. So what's ddx of f of g of x? F prime of g of x times g prime of x. So this is where we get our formula from. Remember, the goal was to find the derivative of the inverse. The goal was to find g prime. So can you see if we just do a little division? We got it, right? So we're going to say that g prime of x is equal to 1 over f prime of g of x. Whoops, sorry. Okay, so that's the formula right there I put in the box, and you can choose to memorize that if you want. You can choose to kind of get that little process of derivation down if you want as well. But one way or the other, we need to arrive at that as kind of our starting line for finding derivative of an inverse. Question?
If we use that in the AP test, will it count?
Totally. Yep. The only thing you'd want to be really clear about is that you're defining the inverse of f to be g. You want to be really clear about that. But yeah, other than that, no problem. And often they'll define it for you because they, similarly, they don't want to have the issues with all the prime stuff. So can I show you the alternative formula that I don't like? So here's what it looks like if you don't use g's. It's such a simple thing, but it's a huge help. So check this out. If g really is the inverse, then here's what it would look like. Do you see why that's not as nice? Do you see all those minus ones and primes all kind of look the same, and which one goes where? To me, this up here is much better than that, simply because it removes all that stuff, extra stuff that gets confusing. Make sense? Okay, so I'm going to erase that because I don't really like to look at that either. All right, so we got this right here. So again, that's the formula we're going to use. A few little things to navigate as we use it, though. Do you have any questions? Okay. So you're going to be kind of surprised at one of the steps we do here. I'm excited to see what you do with it. We're going to do example number 1. Okay, you guys ready? Here we go. Here's how we use this. It says find the derivative of the inverse of f. So the first thing I'm going to do is I'm going to say, I want to get out of your way of writing things, and I'm just going to say the inverse of f is really g. All right, so I want to avoid using that -1 notation. I'm going to use g notation. Make sense? Just to make it easier on myself. And then my next step is hopefully to remember that formula or derive that formula, whichever way works for you. And I'm going to say g prime of x is equal to 1 over f prime of g of x. You want to start with that basic format for a question. Okay, so I would say that like the typical way of asking this is to say, find the value of the derivative of the inverse at a specific value of x. Like in this case, x equals 3. So that's very typical. So as you guys know, plugging in x equals 3 just means plugging in a 3 for x. So I'm going to do that next. So you really could have started off right here if you wanted to. G prime of 3 is equal to 1 over f prime of g of 3. So here is where the next and really the only significant challenge in this process comes. So the first property we looked at is the composition of inverses always gives you x, right? But the other property that's important here is with inverse functions, functions that are inverses of each other, the inputs and the outputs get switched. So here's where you could run into all kinds of trouble if you think, yeah, you know what, formula, schmormula, I'll just switch the x's and the y's and do all that, kind of the way I did in pre-calc. Check this out. If you were to take this formula right here, this equation right here, and you were to try to do just that, we have y is equal to 1/4 x cubed plus x minus 1. If you were to switch the x's and the y's, wouldn't you write this? If I were you, I would not write this right now. I'll erase this in a second. Wouldn't you write that? Wherever I see an x, I write a y, and vice versa. So now let's take that and solve for y. Good luck. It's not going to go. It's just not going to go. You're going to be like, oh, sure, just factor out a y. Oh, wait, no. I don't know what to do. No, you don't. Nobody does. You can't do it. You cannot explicitly solve for y. Okay? Make sense? And so instead of looking at that and thinking, hey, I'll solve for y, we're not going to go that route. What we're going to do is this. We are going to use that idea of switching, but here's how we're going to use it. This right here is the input for g, right? G of 3 is the input for g. The problem is we don't have a function for g, right? We don't have g of x equals blah, blah, blah. We don't have that. So here's how we use this principle. If 3 is an input for g, then 3 could also be an output for f. Inputs and outputs get switched, right? So if g really, remember the table we made last time? When we made like a table for f, we made a table for g, and we could see that the tables essentially did this. Switch, right? So if 3 is supposed to be an input for g, then just as viably it could be an output for f. So here's what we do. Instead of trying to plug a 3 in for some x somewhere, we're actually going to plug a 3 in for the output in the f function. In this case, it's a y, right? So I'm going to say 3 equals 1/4 x cubed plus x minus 1. So notice how I took that 3, which is supposed to be an input for g, and I made it an output, whoops, dramatic pause, for f. Thanks, Ben.
Yep.
Appreciate it. So then you might look at this and be like, well, hey, that's neat and everything, but how am I supposed to solve that? Make sense? These will often, I would say, probably 99.999% of the time be on the no calculator part. So how are you supposed to solve this? This is going to be the one time you hear a math teacher say this. Guess and check. I kid you not. Guess and check. I'm not kidding. This is pretty typical. You know, one of the good news, it's not going to be like, well, gee, Lainey, if you would have only picked 21/11ths, you would have had it. You know, sorry, Colin, it was negative 49/13ths, and you didn't guess that, so tough luck. It's not that way at all. I would say, as you guess and check, keep it within like 3 of 0, so like plus minus 3, right? So keep it tight to 0, and you should, like that's very typical. So, you know, if you try out, say like a 1, and you're like, oh, okay, 1/4 plus 1, oh, that didn't work. I better try 26. No, don't do that. Just be like, oh, hey, 1 didn't work. How about 2 or 1, -1 or -2 or something like that. Keep it close to 0. So I'm guessing that some of you probably already figured this out. What x has to be 2, doesn't it? If you plug in a 2, you get 1/4 of 8, which is 2, plus another 2 is 4, minus 1. Hey, look, it's 3. But there's going to be some element of a little bit of guess and check there, but it'll be like the easiest conceivable guess and check as far as the numerical values. If you find yourself saying, hey, I bet it's 7/19ths, you're probably, something's wrong, okay? So we'd say, sure, x is 2 for this. So what we did down here is we said, if 3 is an input for g, that it's an output for f, we found that g of 3 is 2. So I can continue on my merry way and say g prime of 3 is equal to 1 over f prime of 2. And now the good news is, of course, we do have an explicit function for f, so finding f prime will be pretty straightforward. So I'll come over here and do that. So f prime of x is equal to 3/4 x squared plus 1. So to find f prime of 2, since I do have that explicit function for f prime, I just plug in a 2, and what do I get? 4, right? 3 plus 1. So we end up with g prime of 3 is equal to 1/4 for our final answer. So you start off with the formula, just review the process. You start off with the formula. Hopefully you've memorized it, or you know the process to get there. You're going to first thing you're really going to do is you're going to do the input-output switch thing. In this case, it was with the 3. Do a little guess and check. Use f prime, and you're done. Okay. Good news is it's almost for sure going to have one of these questions on the AP test in May as we start to kind of get into that mode. Almost for sure there's going to be one of these. It's worth 1 point. You might think, oh, gee, 1 point. 1 point could make a big difference. And if you know what you're doing, this could be a relatively straightforward point that you could get. So anyway, do you guys have any questions at all? You also see how the more you practice this, the faster you're going to get. So let's get a little practicing. And if you guys could take a look at number 2, please, we'll check that one out. And we should definitely have time to finish with number 3. So here's number 2 right here. This one would actually work using old school methods, but let's practice using our formula for this one. Find the derivative of the inverse of f at x equals 7. With number 3, if you haven't already checked that one out, please do give that one a look and try out that one. So number 3, so again, want to emphasize the need, if you're going to use the g of x notation, I want to emphasize the need to write this. Inverse of G, or inverse of F is really G. That's what I'm going to call it at least. So that enables us then to use this formula. G prime of X is equal to 1 over F prime of G of X. So then we're looking for the value of the derivative of the inverse when X is negative 15. So G prime of negative 15 is equal to 1 over F prime of G of negative 15. So to figure this out, of course, we need to recognize that an input for G is the exact same thing as an output for F. And we have to do it this way because we don't have an explicit function for G. We have an implicit function for G. We're going to have to use that. So since the input for G is negative 15, I'm going to make the output for F negative 15. And this is where you do a little bit of that educated guessing and checking. Keep it close to 0. What is it, negative 2? Negative 2. Okay, so X equals negative 2. So that means G prime of negative 15 is really 1 over F prime of negative 2. And to figure out F prime of negative 2, we just need to find F prime. So F prime equals 6x squared plus 1. And so I get, when I plug a negative 2 in for X, for that I get 25. So my final answer would be 1/25. Are you quiet because it feels easy right now? Is it good? That's fine. Do you have any questions? Okay, so 2 things real quick. Number 1, have you guys, I think you probably figured this out, have you noticed that Chapter 5 is really about skill development? Right, Chapter 3 was about applications of derivatives. Chapter 4 was about integrals and applications of integrals. With Chapter 5, we're kind of back to, hey, here's a new derivative, and here's something you could do with an integral, so on and so forth. And that'll be for the balance of Chapter 5. It'll be all application stuff, or all skill stuff. We won't come back to application until really kind of the end of Chapter 6 and then Chapter 7. And by that time, it'll be March, and we'll be wrapping things up. Kind of cool. Okay. So any questions about that stuff? We good? Okay, awesome. So let's talk then real quickly about